Hello, my name is Louis Kowalik, and I will be demonstrating my group's final project for ECE 2700. It is a digital alarm system where the disengagement code is 1111 and switches 3, 2, 1, and 0 are used as our code. You can see C equals C3, C2, C1, C0, which correlates to switch 3, switch 2, switch 1, switch 0. If this is 1111, then the alarm is disengaged, regardless of whether or not it detects motion. We have a PIR motion sensor, which at the moment is adjusted to output a high signal for roughly 3 seconds. If I put my hand back there, and it'll detect the motion of my hand, and you'll see that the blue LED goes on for roughly 3 seconds. But because our code is 1111, it is disengaged and no sound across the active buzzer will be there. So there will be no voltage and the buzzer will not sound. I'll demonstrate that now. So the LED goes on, it turns off, nothing happens. If we engage by using any other code, so if I use 110 for instance, if I use 110, this 2-second counter will, once motion is detected, it'll count up to 2 seconds, which gives the user 2 seconds to be able to disengage the alarm. Again, put it back to 1111. And if the user does not, then this will output a high voltage through the Arduino into pin 7. And the Arduino has code which says if pin 7 is high, then pin 8, which is outputting across the active buzzer, equals pin 4. And pin 4 is connected with this green wire right here, and it is connected to 5 volts. So that means that if the red cable, which is coming out here, out Y to amplifier, if it goes to the Arduino Uno and it is high, the Arduino Uno will output 5 volts across the active buzzer. This is important because the active buzzer cannot be powered enough. It's not loud enough with just the FPGA's voltage of 3.3 volts. I will demonstrate that now. So we have 1110. So this is not the code 1111. And so if it detects motion, the counter is counting 1, 2, and the buzzer continues to buzz. You'll notice that the motion is not detected anymore, but the buzzer is continuing to buzz. If I put in any other code, it's still not right. It needs to be 1111. Right now we have 0000. What if I try 0100? Doesn't work. Right now we have 1110. It still is not disengaged. As soon as I put in the other one, it gets disengaged. And so we can see that the system works. Here, I will show it again with 1101, or let's do it with 1001. So if we have 1101 and motion is detected, you saw that the counter counts up and that the buzzer rings until the correct code is implemented. There's only one other way to disengage that buzzer, and an intruder would not be smart enough to do it. And if we take off this cover, you'll see what I am talking about. There's a button called CPU reset, which is reset FSM on the state diagram and in the code. And so if we put that to anything else, and if we show motion, we can also press that button to reset. Again, that would not be viable for the intruder because, again, this has a cover on it. And that is everything that needs to be shown for this final project. It works exactly how it is meant to. Thank you so much for watching. I hope you enjoyed. Again, this was Louis Kowalik for my final project group for ECE 2700. We created for our digital system a digital alarm system using a PIR motion sensor.